Good afternoon and welcome to today's presentation, An Introduction to Water Penetration Investigations in Housing Developments. Before we begin our presentation today, I would like to take a few moments to go over some housekeeping items. We will be recording this webinar, and this webinar is CLE approved, and we will be asking that you enter a passcode for CLE credit a few times throughout the presentation. In today's webinar, Mr. Cohen will discuss different parties' involvement and responsibilities, including those of manufacturers, installation professionals, and designers, the investigation process, mitigating factors to the investigation process, as well as other types of documentation that can contribute to the investigation, and field investigation protocols, field investigation limitations, and other considerations that can add to the investigation process. To give you a little background about our presenter, James Cohen, he has more than 35 years of experience in failure analysis, natural hazard mitigation and response, dynamics, advanced analysis techniques, and instrumentation. He has been involved with leak mitigation, demolition, preparation of codes, and standards on wind and seismic loads. Mr. Cohen has also worked with vibration and fatigue testing of major structures, cable design, blast analysis and inspection of existing facilities, and dynamic and impact analysis. In addition to his other responsibilities, Mr. Cohen is also an active member of numerous professional committees and is a former adjunct professor at Manhattan College, where he taught a graduate course in forensic engineering. He has been admitted in court as an expert in structural collapse, engineering investigations, building engineering, concrete, and other issues. For those of our attendees who require a code word for tracking purposes, the code word for today is investigation. During the presentation, we will take short breaks, and during that time, we will ask that you enter this code into the Q&A widget for CLE reporting purposes. The Q&A is located to the left of your screen. Please remember that if you're applying for CLE credit, you must log onto your computer as yourself. Also, please remember to complete the survey that will appear on the right of your screen at the end of the presentation. As a provider of CLE credits, we are required to have supportive information that you have attended, and in many states the survey is required. CLE certificates will be provided within 24 to 48 hours via email. Also, the PowerPoint slides can be downloaded from the Resource Center on the left of your screen. Mr. Cohen welcomes your questions. Please use the Q&A widget to submit your questions throughout the presentation. We will take intermittent breaks so that Mr. Cohen can respond. Thank you all again for attending today, and James, the presentation is now turned over to you.
Hello, everyone. Thank you for attending, and good afternoon or good morning, as it may be where you are. I'll be talking on an introduction to water penetration investigations in housing developments specifically. It's only an hour long. There's a lot of material, so there may be items that I gloss over quickly. You're welcome to ask questions at appropriate times. The objectives of the presentation are to go through water penetration locations, water penetration causes, the various parties that may be involved in their responsibilities, manufacturers versus installation versus design issues, what happens with suppliers, defects, whether to test or inspect, safety issues. Now, one disclaimer, although I know most of the people on this call are attorneys, this is a disclaimer I use in all of my presentations. I do not provide legal advice. I am an engineer, so I can provide you with technical advice or my take on what I have seen in contracts. If you need legal advice, consult a lawyer, not an engineer. Typically, I also ask if anyone in the room is from the press. I hope that there isn't anyone today. I'll be able to talk more freely. Now, first, I'd like to start with just a pop quiz. And this is quite important for your perception of forensic engineers. Outside of the difficulty making small talk, what do homicide detectives and forensic engineers have in common? A few moments just to ponder that. The answer is a search for the truth. And the photo you see is of Rene Descartes, who is credited with inventing or being the father of the scientific method. Now, per Jack Valentine, who gave me permission to use the following couple of slides, The investigative process, according to him, is to seek the truth. That was the key item. Follow the evidence, collect items to support the facts. Never investigate to a predetermined conclusion. Never lose sight of the evidence that presents itself. Follow all evidence and conduct all follow-ups until all data is collected. And to remember that you are a fact finder, or the forensic investigator is a fact finder and a reporter of facts. Never to lose sight of that. The question may come up, who is Jack Valentine? Is he a forensic engineer of note? No, he was a Phoenix police officer and quickly rose to the top as one of the world's most successful undercover operatives. I met him at the Property Loss Research Bureau conference just a couple of months ago. He was the keynote presenter, and I was very impressed with what he had to say about the investigative process, which is why I have his slides. Now, why are there water penetration claims? First, we'll assume that there's failure. That's always a question as well. The big three, which are usually looked at, are design, construction, or material defects. Now, these are often linked, and they are often contained in contractual obligations, but in this presentation, it is considered to be unrelated to what the contract says. These are the physical conditions that cause water penetration claims. Why are there water penetration claims? Again, assuming failure. There are other causes besides the three that I mentioned. There can be outside loads, applied loads. There can be alterations to a structure or a building. The usage may have caused the defects or the problems to occur. Maintenance or lack of it. Just general aging. There may be material incompatibility, which is separate from a design or construction issue. Other causes, such as vegetation, can cause water penetration. The disasters that we're familiar with. And lastly, when all else fails, we go to the unknown as being a cause. Now, what are the common downfalls of water penetration investigations by the expert? This is usually, at least to my experience, lack of correlation of a defect with water penetration, lack of correlation of a specific damage to a specific defect, lack of accepted test methods. How is this played out in the field? Someone sees damage on the inside, they see a defect on the outside, and they go, aha, this is the cause of that problem. And often it is not. It needs to be proved. If one sees a penetration on cladding on the outside, that may be completely unrelated to the water damage, which may be in proximity on the inside. Test methods, there are spray tests, but I have seen people just take a garden hose and hit the building as hard as they can with a high-pressure spray, almost guaranteed to get through one way or the other, and that would not be accepted. There are ASTMs, which I'll get into later. There's also a failure to use pertinent codes and standards, not just in testing, but related to the investigation. A repetitive problem that I come across are experts who use an outdated code or a code which was not present at the time of the construction. They try to apply new criteria to old problems. There may be a failure to acknowledge that there are mitigating issues. Typically, this happens with the defense experts, where, say, the expert has a client who is representing the external insulated finish systems, and they will then put the blame on the roofer or the flashing at the roof, completely ignoring that there may have been other issues which the EIFs provide. Or they may be looking at one issue and forgetting that there may be many others. That's related to acknowledging contributory issues. They may not see lapse time. That's related to aging, where the amount of time that goes on can result in a problem irrespective of what the original construction and design may have been. Experts are also quite prone to spoliation of a building. It has happened many times where I have been on a project, and by the time that I've been there by the client, the building cladding has been replaced in its entirety. And in fact, it was replaced in its entirety before any of the defense experts may have been able to get to the site. There may have also been repairs done by, say, the condo association prior to their own expert being on site, and no one has really any idea what was there originally. And then there are false statistical inferences or inadequate evidence. An example of that was a large building on the Jersey Shore where there was a claim that all the windows were faulty, causing water penetration. And indeed, there were a large number of windows which had resulted in water penetration. In fact, 100% of the windows that were investigated caused water penetration. However, when looking at what had happened, the engineer who had decided that the windows were a problem only looked at the windows where there was clear water damage on the inside likely to be related to the windows on the outside, failed to acknowledge that the windows were all on one face of the building, being the face most likely to get rain and various other weather phenomena, and also failed to note that those windows had been put in by a particular subcontractor and were not common to the rest of the building. In all these cases, the expert is acting as an advocate. If you remember one of the earlier slides from Jack Valentine, one must have an independent thought about, not come to a predetermined conclusion. What are the common downfalls of engagement by the client? That would typically be the attorney, but it could also be a loss adjuster, an insurance company, or the building owner of an expert. First is lack of an adequate budget, and conversely, an excessive budget can also be a downfall. If one is not able to carry through the investigation to a conclusion will be premature and may be undermined by other parties. Restricting the scope. Say there's a roof issue, but the person who is out there looking at the building is there for sealant. There may be a restricted scope to look only at the sealant, and then they will not be able to get the mitigating issues which arise at the roof level, which actually cause the damage, only looking at whether the sealant is a problem. A failure by the client to provide all necessary documents. This would be coming under often lack of an adequate budget, which was available in order to do an investigation. I have been on the stand where I was provided with documents I had never seen, and they did in fact change my opinion to some limited degree. Also, directing the expert. That's similar to restrictive scope. This is separate from the ethics issues which I know attorneys have of directing an expert or writing the opinions for the expert, etc. But this is pointing the expert to look at a certain area and not to look at other areas. Unrelated to water penetration, I was lead investigator for the 51st Street tower crane collapse. First day out by the DOB, I was told to look at the welds as being the likely cause of the failure of the crane. Turns out they were unrelated. And then late engagement. Waiting too long to get the expert results in spoliation, or if not spoliation in a legal sense, lack of any physical evidence to do a proper investigation. Other items are failure to notify of deadlines so that the report becomes due 2 days or 1 day after the notification. Not knowing about visits, not knowing about tests. These are common issues that come up. Failure to accept contrary conclusions. The expert is not the advocate. That is the attorney's job. So the expert may end up having conclusions which are not favorable to a client. It's necessary to accept those and, as part of advocacy, mitigate the damage that may come from that. There may be a failure to assess damages or a failure to request the expert to assess damages. Again, one very early trial that I was an expert in, we won on technical grounds, but there were no costs that had been produced relative to the damage that was claimed. So the judge awarded us technical grounds, but gave the client only 1 cent in damages. And then failure to adequately inform the defendant plaintiff. They should know what is happening and where they are going so they can also have an idea of where they stand in the outcome. Result of these downfalls by the expert or by the client are excessive litigation costs, excessive expert fees, excessive time to resolution. These are separate from issues of ethics and rules of evidence or expert testimony, as I mentioned earlier. What are the possible primary penetration locations? I refer to primary, and if I do a top-down list, obviously the roof is the first, and roof goes with penetrations, with chimneys, with crickets, with the flashing that goes on, with skylights, which are notorious for having water penetration problems. Sealant is present at the roof. It's actually everywhere, but I put it here because it's at the roof as we're moving down. Flashing or lack of it. Usually this is associated with materials other than the roof, but the roof has its own flashing problems, although typically they don't show up as being a primary cause of water penetration. The roofer usually fails in some other fashion. Windows are often caused or alleged to be problems. You have the cladding, that's the entire building envelope of any type, whether it's brick, stone, manufactured stone, eaves. Then you get to your foundation, which can be the cause of the water penetration problems, and if you have a slab on grade or a slab at the bottom, you can also get water coming up. In essence, anywhere on the building envelope is a possible penetration problem. Roof penetration claims. Loads are the common cause of roof claims and defensive claims. Typically, these include wind, rain and ponding, snow or ice, and hail. The photograph to the right is a building. It's actually not housing. It's an industrial building. There was a large buildup of snow, which you can still see. The roof caved in just beyond that point, and that was due to snow loading. However, the investigation included construction and design of the joist, the roofing, the maintenance, how the roof had been used, and other issues that were related. Other items besides slow loads include deflection, thermal loads on the roof, differential thermal expansion, and roof traffic. Sample alleged issues specific to roofs can be the presence or absence of an adequate ice shield, the slope of a roof, sheathing on the roof below your shingles, the type of sheathing, the gaps that may be present, nailing, whether they're clips, whether they're supported properly. The shingles themselves, again, the same type, lapse, nailing, or other damages that could have taken place from people being on the roof, from hail, pre-existing damage. Penetrations, I mentioned earlier. Flashing, there are many different types of flashing which are related to roofing. They all may contribute to a water penetration claim. Typically, in this particular list, diverters are picked up as being a cause, mostly because they may be absent, and step flashing around chimneys is more common than other causes. Gutters and downspouts are also sometimes flagged as being either inadequate or missing. The photograph, which you see on the right, is the interface between an older building, that's the shingle face, and a newer building which was built next to it as an extension, that's the white wall. What was left was a narrowing gap between the steep slope and the vertical wall. The water would come down, it was funneled at the base, and ended up causing a good amount of damage at the ground level due to the overflow of the gutters. The gutters could not handle the water. Sealant water penetration claims, almost guaranteed. If you have a building, there is sealant, and if there is sealant and there's a water penetration problem, somebody will say it was the sealant. Sometimes it is, sometimes it's not. This is where looking at mitigating issues and other contributory factors becomes very important. Sample alleged issues is the type of sealant, the detailing of the sealant, that's most common, the type or absence of a backer rod behind the sealant, compatibility of the sealant with the surrounding materials, the substrate preparation, that's how do you prepare the surface before the sealant is put on, the actual application, size, etc., and whether there are any gaps. The most common issue I see coming up with sealant is either the lack of sealant at interfaces between materials or the application of sealant to the finish coat of external insulated finish systems, which does not necessarily create a failure, and even if it fails, it doesn't necessarily create water penetration, but is considered to be bad practice. With windows, they're fairly limited. Windows are made of only a few materials which are put together, so the window issues which may come up is the actual specification for the window. That would have to do with wind size, wind loads, the size of the window, the joining of the windows, particularly for ganged windows where you have, say, two sash windows which are put together in the field. Those are often actually a cause of water penetration as well as a claim. The seals of the windows, the lights, the seals there, the sealant that goes around the window and how it's been installed, Particularly for finned windows, weather sealant is present at all behind the fins. That's often looked at as the last line of defense, and they are often faulty. Condensation, which is a form of water penetration, it can also occur, and that may arise from thermal breaks or lack of them. Window water penetration claims, again, sample alleged issues with construction and detailing. Is the framing, performance of the window, fins or lack of them, the nailing, the weather-resistant barrier, the building wrap, and the sealant. That's a list. They all go together. They all have detailing issues. One needs to go on before the other. They need to lap over each other so as to shed rather than collect water. And these are the issues that would come up mostly with windows. Cladding penetration claims. If you notice, the picture is the same because windows and cladding go together, as do sealants, windows, and cladding. Sample alleged issues is the type of cladding that may be used. A recent example is a stacked manufactured stone veneer where the stacking means the stone had no grout put between the stones as an architectural feature. That works in dry areas of the Southwest. It does not work in very wet and freezing conditions as you would have in the Northeast. Drainage planes are a common complaint, as is the presence or absence or blockage of weep holes at the base of the cladding. Building wrap may sometimes be absent altogether. That's unusual. What's more usual is that it's been lapped inappropriately. The laps are too small so that the water can travel around them even though they're vertical, or that the contractor, one way or another, has cut the building wrap in order to put other pieces in, causing water penetration possible. Then you can get simply the joints, the cracks, specifications come up with the experts. Framing, that is the support of the cladding, may be an issue. It's rare, but that happens. Penetrations through your cladding is common. The cladding will go on, then your plumber may come in and put on the plumbing fixture. The electrician may come and put on the lighting fixture. These make holes in the cladding, and there is an interface issue which may not have been dealt with, and it is left unprotected. Diverter flashing, which would be near the eaves, roof level. Nailing patterns or the types of nails can cause problems long term. Ground clearance, is it clear of the ground or not? And in this, codes have changed, standards have changed. So if one is litigating a water penetration claim and is looking at ground clearance as one of the causes, it's important to know what was the practice, the accepted practice at the time. And of course, sealant is always in this list. Foundation slab water penetration claims. Usually these get into the basement, but you may also have complaints at ground floor wood finishes on your drywall, things that may look as though the water is traveling down and then entering the house, but it could be coming up from the bottom. Has to do with ground drainage, whether it's sloped properly. If you have waterproofing on your foundations, and it's hard to believe, sometimes waterproofing is not put on, or someone uses a lower spec using damp proofing, which will not have the same performance as a waterproofing application. Joints in your foundation may not be able to be bridged by your waterproofing, cracks which may occur afterwards. Specifications such as loads is pretty unusual as being an allegation of water penetration, but it does happen. The quality of your foundation can have a bearing on it if the concrete is very porous, improperly cured, is honeycombed, or if your block wall is hollow, again, very porous. They may also contribute to water getting through. Plumbing level is unusual to put in, but it would be as a general catch-all. Penetration, such as for cladding, can be causes of water penetration after the foundation wall is complete. Someone puts in a drain line, and it's not properly flashed or sealed. Ground clearance is pretty common, and a normal cause of ground clearance is not the original design or construction, but the homeowner who may be adding mulch on a yearly basis to the surrounding to keep the foliage nice. And that mulch, in a short number of years, may go over the top of the waterproofing and may even go over the top of the foundation and end up in a situation as you can see in this photograph. And then the water table itself may be a problem where it wasn't properly determined where it was or that it may rise. Now, getting into failure itself, this is a slide I use in classes that I give to engineers on failure. And what is a failure? In my mind, failure is the inability to perform as required, or to a lesser extent, it's the inability to perform as intended. It can be the inability to perform as anticipated, or it may simply be the inability to perform as desired. And they all have different types of causes which have priorities associated with them. The first would be more related to codes and regulations. That's the requirement. Contract and specifications, that's as specified. Whether or not it meets the brief. Industry standards, manufacturer's warranties, that's what is expected, despite what the contractor specs may say or the codes or regulations say. And then after it's all built, the expectations of the client and whatever a designer may have promised may then supersede the others in terms of what was expected by the client, and that can result in a claim. They in all different forms of failures. Again, in terms of what is failure, this is my own opinion that if there is no water penetration, then there is no failure, regardless of whether it complied with codes, regulations, contract specs, etc. That doesn't mean there isn't a claim that it didn't comply with codes, but I do believe that there would not be a claim then that there was a water penetration problem. However, there would still remain the possibility of a failure to perform in the future, as well as a loss of perceived value. So if you're not getting any water penetration today, it doesn't mean that you may not get any water penetration tomorrow. And if you don't have any water penetration tomorrow, when the building is sold, it may still have a loss of value due to a defect in the original construction. When engaging an expert, first of the questions are the scope of work. What happened? How did this happen? Why did it happen? What could have been done to prevent this? What can we do now? And particularly for litigious projects, who did it? The who issue is never present when, or I've never found it to be present when there isn't litigation involved. I'll take a brief moment for any questions which may have come in.
Okay, and before we begin the question and answer segment, could all of the attendees please type the passcode into the Q&A? Okay, the first question is, what is the most common allegation on water penetration?
Well, by far the one that comes up the most is on sealant. Wherever water gets through, usually there's a joint present. It's rare that there isn't some interface issue which will be existing. And where there is an interface, where there is a joint, usually there's sealant. The sealant usually has the lowest life of all the other materials. I've seen lifetime predictions for sealant as low as 3 years with maintenance on a yearly basis. Typically the claims don't come in, or they may extend for 5 or 10 years. So the sealant will almost necessarily be in a condition where it looks as though it's failed, and so that it's typically brought in. I would say that's the most common complaint.
Okay, HOA Board of Directors contracted with water intrusion company to resolve a problem. They made it worse. What would the liability be?
In the experience that I have, certainly in the reports that I might write, the original problem may still be there, but the exacerbation of the problem would not be the original designer or contractors or anyone else's fault. Now, if there had not been a problem, or if it can no longer be proved that there was a problem, then there's a difficulty associating the new increased problem with the original conditions. That would be back to that spoliation and aging issue. There have been several projects where the litigation went on for so long it passed the warranty period of the original construction, which was still not yet leaking. There were allegations of the design or construction being a problem, but there hadn't been damages yet. And in that case, there was no cause anymore for complaint. It actually lived out its useful life. A bad way to experiment, but that happened. I hope that I answered the question.
Okay, the next question is basement penetrations. How would you determine the source of the water?
Going into a basement, first one needs to be able to see the walls, needs to be able to see, not just that there's water present. I would look for crack patterns. I might use, well, I would definitely use a moisture meter, develop patterns of dampness on the walls. I'm assuming that they are concrete, cement block, or a similar material, and they are not an older form of basement. Infrared thermography might be a method to use, but it may not work in the basement environment. Most expensive method would be to dig out on the outside, but that would typically be at the end or as part of a repair method. So I'd be looking for patterns, preferably from the inside. On the outside, if the top of the foundation is exposed, or it can be exposed with shallow digging, I will typically carry a small trowel just for this purpose to see if the waterproofing membrane extends up high enough to prevent water, and to see if there are any cracks, does it bridge the crack? But the ultimate method is actually to dig out. Looking at design drawings is always a time-honored method by experts or engineers in general. The problem with looking at design drawings is that they typically don't reflect the as-built conditions. Whether or not that itself is a claim is a different question. Next question.
Okay, how often do you find a problem with the neoprene gaskets, such as shrinking from exposure, too little put in, etc.?
Haven't come across that very much. Usually if there's a gasket issue, it's more that it didn't fit, it wasn't installed properly, or it wasn't inspected and maintained on a regular basis. It's not one that I am too familiar with. Sorry, I can't give more on that.
Is there a non-destructive technique or tool for locating water outside the foundation?
If you're considering looking at water outside a foundation which is buried, I don't believe that there is, other than doing water testing and seeing if one can locate water on the inside coming in from the water test on the outside, but because the water will disperse through the soil, it will not give a very good answer. If your foundation is exposed, then we're back to looking for patterns, crack patterns, moisture meter readings on the outside surface, and in this case, thermography might be better because we have a change in temperature going on between the inside and outside. On the previous question on neoprene,
those are all the questions we have, so please continue with the presentation.
One item on the questions, if anyone does have a question and they feel it wasn't addressed or they weren't able to ask, please feel free to send them in at the end of the presentation. I'll do my best to give a full answer. A typical start of an investigation project, there's a claim filed or there's a potential claim reported, and it's also often who is involved. The reality is that absolutely everybody is involved. It's until one can prove that they're not there or it's frivolous, then everyone has a potential impact. What are the consequences of the failure or the alleged failure? Is there an economic loss? Is there a serviceability loss, meaning is it loss of function? Is there a consequential damage? Is there a third-party loss? Are there any injuries or fatality? That's pretty rare for water penetration, but it can happen. The photo you see to the right is the interior of that snow-covered building earlier. The roof had caved in. Clearly the roof was a claim. The joist, the structure was a claim. But what was actually the biggest claim was the equipment damage, which was a write-off. It was a new industrial facility, and they had to replace millions of dollars worth of equipment. Now, the complaint itself, it's defined as a contract scope for the expert. When I do defense work, I look at what the complaint is, and that is what I will be addressing. That doesn't mean I don't look at mitigating factors, aging factors, and items which are unrelated to the complaint itself. But the complaint is the focus of the work. For a plaintiff engineer, they may be asked to assist in determining a complaint. Where are the problems? Who might be involved? How extensive is it? Are there other issues that may be up? Now, potential issues which come up, which have to do either with a complaint or with defense of a complaint. With the owner, there's use versus abuse. There's the maintenance, whether it's occurred, and exclusions, which are particularly important for the insurance policies. The photo to the right is a roof which has not been maintained, and there were trees growing on the roof which had then caused cracking in the concrete, resulting in water penetration and severe corrosion underneath. With regard to the designer, they are often named in a lawsuit with regard to water penetration, even if the original design was adequate. But the questions are, was the original design signed and sealed? Did they accept the owner's terms? Do they accept the manufacturer's information that came in? Did they accept the contractor's work? Now, I have here if inspected, but if they need to approve the payments and are using the standard AIA forms, one may wish to argue that that deems that they did or should have inspected. And did they accept change orders? Did they know what was actually built? Did they have responsibility for ongoing construction? Getting on to the GC and the subs, they needed to accept the design by the design professionals. They need to accept the materials that are provided. They installed it. They will have supervision responsibility. They are responsible almost always, not absolutely, but nearly always, for the means and methods of installing these materials. And then they also usually have the responsibility for issuing and obtaining the warranties. All of these are potential issues for them if there's a water penetration problem. When you get to the manufacturers and suppliers, again, they accepted the design. The architect or the engineer may provide a flashing or waterproofing detail which flies in the face of what would normally be done by the GCs, and it doesn't follow what the manufacturers would normally recommend. But if they accept the design, that's a different matter in terms of whether there's a problem with the design itself. They accepted the installation, particularly if they are out there to look at the installation as it's going in or the final product, in order to provide those warranties which are typically requested. You see, there's a lot of overlap between all these parties. Now, at the commencement of the investigation, I keep saying a failure, but it's a failure that's perceived. One of the first items to do is confirm that the perception is valid. There may not be any validity to the claim that there has been a failure. The photograph on the right is not a water penetration issue, but illustrates the point. This is actually a claim that this lolly column was placed in the wrong place on a prefab truss joist, thereby putting loads into the joist, which could cause fracture of that bottom cord. Now, you look at it and you think, that lolly column really shouldn't be there. It should be at a strong point. It shouldn't be in the middle of a span which has no support above it. However, the reality is that this lolly column was placed because it was part of an option by the designer builder, the developer of this building. The option was not used by the owner. So above this floor, there is nothing. There is no load-bearing wall. This lolly column does not see any load, and if one climbs a ladder and looks at the top of that lolly column, it's not actually touching the wood. So there's no transfer of load at all. It looks wrong. It looks as though there's a problem. It was put into a complaint. The reality is it did not have any bearing on a functional loss of any kind. Then what's the alleged failure? We've been through whether it's the GC, the designer, or the sub. Is it a material failure? Is it a systemic failure? Is it a system failure? So the individual materials are okay, but the way they've been put together no longer meet the criteria for a successful system. The EIFS, external insulated finish systems, are typically brought up as an example for that. Is there a component failure? And is it likely? Is the failure which is being perceived a likely failure? Now, when I talk about these things with people, once there is a failure, clearly most housing developments do not have failures which result in litigation. There may be punch lists, but most of them do not sue the designer, the contractor, the suppliers. So as soon as you get into that level, we're looking at a small subset. So the likelihood of failure goes up. It's simply an issue of the probability of things being wrong. What are some of the mitigating factors to the investigation? This has to do with an earlier slide. It's a little bit of a repeat on the expert and the client. Is the scope limited or unlimited? Is the information going to be written or physical or both? What is the time available, which is not a fault of either the expert or the client. It's simply how much time is there to do the work. The budget. A question I will often ask a client is, what is the size of the claim which is being pursued, or what's the possible size? Because it makes no sense for me to issue a proposal having a fee which is in excess of the claim. The scope of work for the investigation should meet what the potential reward or disreward may be on that project. And then what's the expertise involved? I have seen mechanical engineers acting as roofing experts. I don't know why. I have seen structural engineers acting as hazmat experts. Again, it's fine in some sense when they are starting to do that. I would say it's unethical and doesn't meet the licensure requirements. But when it actually gets to the report and testimony, it will fall apart. The purpose of the photograph is the claim or the investigation on this particular building had to do with the masonry on the other side. During the investigation, Hurricane Sandy came through, and this is the result. The EPDM was all lifted up. There was severe water penetration going through. It was unrelated to the claim. So the scope did not include the roofing materials. Document collection. For all of you who have gone through discovery, you know what this involves. It can be extensive. The amount of documents may be enormous. Sorting through and finding the right documents can be very difficult, time-consuming, and therefore expensive. However, it's very important not to limit your expert too much in how many documents they can look through. They're the technical expert. You may not spot something which is relevant to their investigation. On the other hand, it's important not to have them go through reams of material which are clearly going to be unrelated to the problem. This is a full list of these things. It goes on in terms of the number of documents that may be available. On the other hand, I've been involved on projects where the building no longer existed by the time a complaint came in, and the only documents that were available to review were the photographs provided by the firemen and the police and their reports on the building. That had to do with the fire damage. Again, looking at photographs, I mentioned photographs for a specific reason, as they tend to be some of the primary evidence used in reports and the primary evidence which is brought into court because you can see them, you can touch, not so much touch, but they're the most evident. A lot can be done with photographs. This particular is of a roof deck, a multi-level parking garage, which I took. There was an issue that was potentially there with the deck having to do with problems with water penetration and with the concrete and the waterproofing compound. Now, the next photograph is the same roof with the same photograph, but it's what can be done to show where cracks are located. If you look closely now, you'll be able to see cracks in that concrete being reflected through the waterproofing or the membrane on the top. It's simply changing the features. So photographs are more than just a record of what one saw on site. They are also a diagnostic tool which may be missed by your expert. It's important that they have good quality photos and they can do these type of things. It's a little different from most of the other equipment where what you get is what you see is what you get. With documents, what you read is what you get. Photographs have an extra feature of what can be done. Now, there are other documents which become official documents beyond discovery, and this is where the expert may be doing their own investigation, and this is what they are collecting. Invoices may or may not have been supplied. purchase orders, but then you get to the manufacturer's technical literature, their specifications. Is it a 1995 installation we're looking at that was then manipulated by someone or modified, and the claim is coming in with a modification? You need to know it was there originally. Or is it a 2014 construction? The literature of the time is something that needs to be found. The warranties, how have these changed over time? Payment records, canceled checks may not normally be looked at, but they could also reflect who was providing what. That there is an invoice doesn't mean something was provided or it was not accepted. Delivery notices. Testing inspection records from outside agencies and appraisal reports, as well as the building officials' records of a building, are all valid. These are the type of things that the expert may look for, which go beyond the discovery process. There are also items, site diaries, personal diaries, correspondence. Those can come into discovery, but manufacturer's literature is very important to get that coincident with the time that the building was designed, not just constructed, but when the design process, when the specs went out, when the bidding process was going on. If there was a long delay, but the codes don't change, then the old manufacturer literature may be what is pertinent, not the newer material that came into being while it was being constructed. Construction, security cameras, video. This is pretty unusual for housing development investigations, but sometimes there might be something in there, if they exist, which is also unlikely, showing some means and methods or delivery of materials which are relevant. And then we've got our modern methods of looking at Twitter and Facebook, LinkedIn, and phone records. Again, unusual for housing development, but maybe something shows up. Post-claim documentation. This is almost all entirely the expert's purview as to whether or not they look at this. The codes, which would include the current code, historical codes, comparing the codes, and that would also relate to the standards, manuals of practice, committee minutes, on these standards, what was meant by the standard that can be there, historical records, research reports, etc. There's an interesting item on this with regard to timber. One can go to the code and look up the safe load capacities for timber. Determine the species, determine the grade, you get your span, and it pops out there in the code. It says you can have a certain load, or if you have a certain load, you have to have the species and grade. If one goes to the background of the code, they'll find that it's based on a 95 percentile, I believe, of acceptance testing, which has a factor of safety maybe of 2 or 3 put into there. And the reality is that the safe load-bearing capacity of timber joists is typically much higher than is assumed in the code. It becomes important if someone says that the span is too long for a particular joist, or the grade stamp on the timber isn't high enough for the design. Because the reality could be that the actual timber put in is still far superior to what was assumed as part of the safe code tabulated values. That can be have a large mitigating effect on various claims. Same will go true with all the other materials, water penetration issues, and pretty much all construction issues. Post-claim documentation, these you'll be familiar with. You get expert reports that get distributed. There are investigation reports, which may be separate from expert reports. Those may or may not be available for distribution. Witness statements, complaints. One thing on witness statements, they are probably among the worst evidence that I typically will come across. Unless the witness statement is taken by a professional investigator who is trained in taking witness statements, and it's taken very close to the time of the incident, whatever it may be, it will vary according to memory, perception, a view of whether they themselves may be exposed by what they say. And typically they're a last resort for obtaining information that I have come across. With regard to the fire, police, and ambulance that was listed there, usually that means that there has been some other problem beyond just water penetration. But it's important to remember where these do exist, the people writing them are not technical, and they cannot reliably come to a technical conclusion which is out of their own expertise. This issue of expertise is important in document collection for interpreting items. I cannot work outside of my own expertise, much as I may like to. I cannot. If I go to a building, it's an old building, and it appears that there are PCBs, asbestos, biohazards, mercury, lead, whatever there may be, I am not a hazmat expert, no matter how many times I've been in a building. I should not reach a conclusion as to whether there's hazardous materials. I can, however, reach a conclusion that I can recommend that someone check these items based on what I've seen in the past. Now, site investigation, questions come up, non-destructive versus destructive. Non-destructive visual evaluations, and you may want to jot this down, are very similar to the ASTM standard E2018. They're hands-off, they're visual, they may involve metrology or measurement, dimensional measurement. Videography can be done, photographs. Any testing would have to be non-destructive and in some cases without contact. Now, if one is working for the plaintiff, it's much easier to get permission to do a probe or to put 2 pins through a wall for moisture meter or to do other items in the building. But if one is working for a defense side, for the defense client, the owner is unlikely to provide permission to do any test to a building which will involve destruction of some kind. So non-destructive testing will tend to be limited to thermal imaging, to non-invasive moisture meter, which is less accurate but still gives a reasonable relative value. Coating thickness meters, not terribly relevant for water penetration, but it's one that would be allowed. Tachometers, which are used to determine where reinforcement is effectively a metal detector, but a little higher level than that. It can tell you rebar size or depth for foundation issues. And there are some other non-invasive test methods, but they're fairly limited. Destructive testing, on the other hand, as you can see in this photograph, it's hands-on. Typically, there has to be owner permission. Doing destructive testing without permission is, I think, foolhardy. Often there may be a waiver of liability required, particularly if the engineer is not working on behalf of the owner. It can include probing, which is highly destructive, material sampling, destructive testing, and water testing. Water testing is destructive in that the water is penetrating through and it's causing more water penetration problems typically. By the way, this particular photograph is, I would say, the best probe I have ever witnessed. I did not do it myself. It was done in a highly methodical manner. It is not a laboratory example. The investigating engineer had the contractor carefully cut out 2 dimensions, each layer, and then moved in so that all the laps, all the different materials could be easily seen at the very end, and they were labeled. I've never seen one quite like this, aside from this one project. It was really fabulous. Field investigation objectives. It's real-time data collection. You get as-built condition confirmation. When I say as-built, it's as-built at the time of the investigation. It's not as-built as at the time of construction. If there were modifications or repairs, aging effects, which I've mentioned previously, what you see may not be what you got in the past. There will be also as-built performance confirmation with the same caveats with the word as-built. Preservation of evidence is an objective. It doesn't happen when there's destructive testing, but one wants to keep what was there as much as possible, and if something is removed, it's best to retain it unless all parties agree it can be thrown away. That includes the avoidance of spoliation. In terms of experts on site, one is always, or I am always wary of one expert picking up a piece and walking away with it, which I have seen many times in destructive testing. Other objectives, identification of possible hazmat issues. I've mentioned those as things that I have seen. Going into existing buildings or older buildings can have very high hazmat issues as well as confined space problems. Access may be a limitation. Getting to where one needs to be is itself often a problem. The identification of possible contributors to the issue. I listed at the beginning all the different parties that are possible to be involved in any of these cases. It's an objective to determine who is likely and who is not. I have seen a land surveyor called in for water penetration problems simply because he happened to be on the team of the developer. Clearly he had no responsibility for the design, the construction of any kind. He simply laid out the posts where the foundation was to be built, but he was pulled in nonetheless. It would be, at least to me, an expert's responsibility to say this person should be removed from the litigation. They have no contribution to make. Pattern identification. When I give classes to other engineers, identifying patterns or the lack of patterns is a key element to determining what are the water penetration or other problems. Where may they arise? What was contributing? Whether the problems are all upper level, lower level, north facing, south facing. Is it only the stucco? Is it only this brick? Is it only where the stucco meets the brick? Are all the problems around the windows, even if it's stucco or eaves or MSV? It is all possible. Knowing what the patterns are, or if there's any lack of pattern, that can also be important. A lack of pattern comes up where you have many contractors, and they are all claimed to have the same problems. Protocols, these are pretty straightforward. I think more important than what I have written on the slide is this photograph. It is real. It is not staged. The expert for the plaintiff had this contractor grinding brick on a building for various reasons. The contractor put up a 20-foot ladder. One leg is on concrete, one leg is on ground. He's holding a grinder with a cord with no safety and no safety equipment. He has no PPE, and the ladder is not tied back. An item I would like to find out myself is what is the liability of all the engineers, of whom I was one, plus the attorneys who were present watching this. Here's an example of hazmat or hazardous issues which can go up. There are hidden dangers. You can get mold as shown. There are deteriorated ceilings that can often happen when you have water penetration. There's the weather conditions when one is going up. Having the proper personal protective equipment. Whether the access is OSHA compliant, and always having good communications. There are many protocols. These I'm not going to list. This is more to show how many there are. This is only a partial list of possible standards. This one, this particular slide, has to do with windows, and it's only from the AAMA. The next slide is a partial list of applicable ASTM standards for various testing. This isn't materials. These are just test methods. Considerations in investigation analysis. These are the things that should be present in the report, is the contract scope of the investigation, as well as of the parties involved and the various responsibilities and chain of command. The hierarchy of the responsibility, who goes first, who goes second. It definitely is a chicken and egg, but one has to be first. Work coordination, manufacturer's defects, installation defects. I've mentioned this before, acceptance of prior work, consistency of the analysis conclusions, and what the standard of care may be in the investigation analysis itself. Consistency of analysis conclusions, what is concluded must follow, as with Rene Descartes, almost the very first slide I had. It must follow from what you found before. The investigation needs to complete. It needs to point to an answer, not point to a predetermined answer. One shoots an arrow at a target. One does not draw a target around a shot arrow. The standard of care for investigations, we always look at what was the standard of care of the architect or the designer or the contractor. But what is it for the expert? There is a standard of care. Now, the common definition is that degree of learning and skill consistent with a professional skill and care exhibited and ordinarily possessed by professionals in good standing in that profession in the same locality and under certain circumstances. That's the common definition for professionals. However, there is a forensic engineering standard of care. This is a list of most, probably not all, but most of the ASTM standards related to expert and forensic engineering work. It's partly overlapping with forensic science, but forensic science has its own longer list as well. And there is also the guidelines for forensic engineering practice, which was prepared by the Technical Council on Forensic Engineering of the American Society of Civil Engineers. This was published only 1 or 2 years ago. It's not a standard as in an ASTM standard. It's a manual, it's a guideline, but it does represent, by this group, what was considered to be a standard of care for expert and forensic engineers. There's a lot that can be said on ethics. Now, this is not going to be an ethics lecture, and it's certainly not going to be an ethics lecture on attorneys. But there's what is the role of the investigator. If you remember the slides from Jack Valentine, the role of the investigator is to provide accurate information, is to provide accurate interpretations, and maintain a professional attitude. It is not to be the advocate. It is not to be a hired gun. Being a hired gun will mislead the client, that is the attorneys or the owners. That results in the increased costs, increased time, waste of effort. It is not to provide a polemic to try to prove something which cannot be proven. If there are conflicts, these must be disclosed early on, not later. The expert is not a consultant. They're conflicting clients. It is supporting and informing the client. As I say, a lot could be said on ethics. This is a very brief overview. Reports and documentation as well. There's an entire fairly long chapter in that guidelines from ASCE, American Society of Civil Engineers, just on reporting and documentation. There is also an ASTM standard on writing engineering forensic reports. A couple of main bullet points is don't ever write anything you don't want everyone to see. This is common advice, but if experts and forensic engineers get caught in this as well. Assume, and have your expert always assume that anything may be discoverable. And they need to ask you, they need to ask the attorneys, what is confidentiality in this locality? It changes. I've worked in many states, and I need to ask every state, what is happening there? What can I write? What should I not write? What must be live documentation? What can be forwarded? Do I have confidentiality with someone else within my own office? The experts you have need to be highly informed of this so they don't write anything which can be very embarrassing, whether or not it has a bearing on their opinion. And then in the reports, the expert has to be extremely clear as to what is fact versus opinion versus an assumption, and they should not stray from what their area of expertise is. That happens too often. Depositions, they are an item on their own. Then we get into oral information. This is the last slide. Avoiding third-party opinions, which is usually discounted as hearsay. On the other hand, private investigators who get good witness statements might be able to use that. And I believe that in the Federal Rules of Evidence, experts are allowed to use third-party opinions, but they must be carefully identified. And the caveats that are used for this, whether it's an opinion, a fact, an assumption, they always need to be very clearly stated in the reports. And that concludes the presentation. As I say, there is a lot. I've gone through a lot of material very quickly, and I will welcome any questions.
Okay, could all the attendees please type the code that was given at the beginning of the presentation into the Q&A once again? And our first question is, if destructive testing was performed but failed, but failed to find the source of intrusion, what would be the next step?
The destructive testing, if it fails, would often indicate that it was premature or someone is engaging in a polemic. They're trying to prove something which wasn't provable. There should be a good objective to destructive testing. One can't do that type of work on a building until all answers are solved, because clearly there will be no building left to look at. I would say step back, revisit what the objective of the destructive testing was, examine the protocols that were being used, look at what the statistical evidence is that's trying to be found, if any, and find the error in use of the destructive test so that it can be a lesson for anything which is recommended afterwards. That's not to say that all destructive testing should find a problem, but if it doesn't find a problem, then perhaps the answer is that there isn't one.
Okay, and can a foundation of a residence be properly constructed over underground percolating springs leading to water penetration in the residence 365 days of the year? Does the developer's knowledge of the underground springs in construction matter?
I think this is a very specific project which is being asked about. It is possible, if one puts enough money into anything, to design and build almost anything. So if one wants to build a basement which is going to be an effective bathtub for the next 30 years with water running around it, that is possible. And definitely if there's knowledge that there is water running around or under, or potentially under or around the foundation, that should be included, in my opinion, as part of the original design, the care, the construction, and whether there, what inspection and testing may take place during the construction process. If we can have steel battleships floating on the sea, we can build a basement around flowing water.
Next question is, roof leaks that has a valve for the water to come out is not working and the drain overflows. Would you recommend an engineer and forensic engineer?
Can you repeat that, please? You broke up with some of the question.
Sure. Roof leaks that has a valve for the water to come out is not working and the drain overflows. Would you recommend an engineer and forensic engineer?
A forensic engineer is not always needed. If one knows the problem, actually knows the problem is because there's a valve issue, I would address the valve issue and see if the problem goes away. I don't see that forensic engineers would be required for that.
Okay, those are all the questions we have, so we'll continue on with the CLE information for everyone. This webinar is eligible for CLE credit in California, Minnesota, Missouri, New Jersey, Pennsylvania, and Texas. To ensure that you receive your CLE credit, please complete the survey at the end of the presentation. This is a reminder that CLE certificates will be provided within 24 to 48 hours via email. In addition to being your best source for testifying and consulting experts, TASA also offers e-discovery and document management solutions, free interactive webinars, and research reports on expert witnesses, such as the Challenge History Report 2.0, the Professional Sanction Search, and the Expert Profile 360. I want to take this opportunity to thank everyone for attending, and most especially James Cohen for his time and effort in creating this presentation. If you would like to speak with Mr. Cohen, or if you would like to speak with a TASA representative regarding an expert witness for a case that you are working on, please contact TASA at 1-800-523-2319. This is a reminder that we will be sending out a link to you tomorrow with the archive recording. The archive recording will also be posted in the Knowledge Center on TASA's website. If you have any questions or comments, please email Carol Kowaleski. Thank you all again for attending, and have a great day, everyone.